Hey guys, and welcome back to another video. So in this video, I want to share a cool result that I found. We're like finding the Taylor series of a cool function, and it's actually another way to write the binomial theorem. Okay, so let's get right into it. So if we have the function x plus y to the m, and we want to find the Taylor series of this function. So let's just start by taking the derivative. So we call this to be f of x, and let's say it's centered at a equals 0. So then if we find the Taylor series of this, so f of x equals x plus y to the m, which means that f of 0 is simply just y to the m, right? And then if we take the first derivative, f prime of x, we get m times x plus y to the m minus 1. Plug in 0 for x, and you get m y to the m minus 1. And if you keep doing this, you can see how the f of 0, when you plug in 0, is just the derivatives of y to the m, right? So here, when n is equal to 0, right, you're taking the 0th derivative, essentially. It's just a function. Then you take the first derivative, it's just the derivative of this, and it just keeps going like that. So the general rule, if we have the nth derivative of f of x, it would be the same thing as the nth derivative with respect to y of y to the m. Okay? And now we can make the Taylor series. So the general form for Taylor series is as follows. We have the nth derivative and then x to the n over n factorial, and then we can plug in the formula. This is actually supposed to be 0. So then we can plug in that formula for that. So you get the following series. Y to the m times x to the n over n factorial, right? And so this is the Taylor series I was talking about. Okay, and to show you how this is the same thing really as just the binomial series, we can, so let's just, what is the binomial series? So first, let me just like denote that this is the same thing as x plus y to the m, right? And so the binomial series then is just says that x plus y to the m is equal to the sum as k goes from 0 to n of n choose k times x to the n minus k y to the k. I believe that's the binomial series. So then this should be n. Hold on. Yeah, so this is n. Okay, that's the binomial series. So now, and actually right here, it is going from n equals 0 to infinity, but when n equals m, then the derivative of y to the m, the mth derivative of y to the n, just becomes a constant, and everything after m is just 0. So technically, this is the same thing as saying the sum as n goes from 0 to m, because everything after m, the derivative of that is just going to be 0. Okay? And so here, if we just like, because k and n are just variables, we can just like change the variables to match this. And then it would be m choose n, and then x to the m minus n, y to the n. Okay. Okay, good. And actually, we can also switch the variables, because I just wanted to get into this form, so then we can equate the coefficients. So if we just swap the x and y, and that's not going to change anything. So you just swap it like that. And now we can see that this is also equal to x plus y to the n. So x plus y to the m is equal to this, and it's also equal to this. So we can just equate the series. So I'll go over here and I'll equate the series. N goes from 0 to m choose n, y to the m minus n, x to the n equal to, n goes from 0 to m, and then the nth derivative with respect to y of y to the m. I'm running out of room here. X to the n over n factorial. So the indexes of the series are the same, meaning that the insides are the same. And so we can just equate the insides. And then if you notice, both of them have an x to the n term, so you can cancel that. So then you get that m choose n times y to the m minus n is equal to the nth derivative of y to the m over n factorial. Okay. And from here, you can write out the definition of a combination. So m choose n is just the same thing as m factorial over n factorial times m minus n factorial. And now you can cancel out the n factorials on both sides. And so you're left with m factorial over m minus n factorial times y to the m minus n is equal to the nth derivative of y to the m. Yeah. Okay. Okay, so if we just expand out this, we get the nth derivative. So then you're going to have y to the m minus n, and then out front you're going to have m minus n plus 1 factorial, I believe. Right? Because so if you look do an example, so if you have like y, because if you have y to the m, and let's say take the second derivative of this, so then you'd get m times m minus 1 times y to the m minus 2. So this is just m minus 2 plus 1, which is m minus 1 factorial. That's not right. Well, m times m minus 1 is just m factorial over m minus 2 factorial, which is just the same thing as this. So you actually do get m factorial over m minus n factorial. And then there, you proved it. Right. Okay. So that's how you do that. But yeah, I thought it was a pretty cool result. So actually, let me write down the result again. So it's x plus y to the m is equal to of the nth derivative of y to the m times x to the n over n factorial. Right, so this is like another way to write the binomial theorem, and it's derived from the Taylor series of x plus y to the m. And the cool thing about this is that you can like express a binomial using like derivatives in calculus, which I thought is pretty cool. But yeah, I hope you guys enjoyed this video. If you did, make sure to comment and leave a like. Don't forget to subscribe. See you guys in the next video.